Good morning, dear students. My name is Ferhan Mazher, and today is 28th of September 2021. And today I am with the 9th Cambridge class, and we are studying mathematics. The name of the subject is D-Maths 4024. It's O levels mathematics. We are studying the D3. D3 is the name of the book. And we are working on the chapter number 6. The name of the chapter is Coordinate Geometry. We are doing exercise 6D, and this session we will start from the question number 8. So let's start from the question number 8, and let's see. I will read the question from the book. So let me go to the question number 8. Okay. So I'm reading the question from the book, and it says that given that A is the point 0, 4, B is 6, 6, find the A part is the point C on the x-axis such that AB is equals to BC. The point C is on the x-axis. Whenever any point is on the x-axis, the y coordinate will be 0. Any point which is on the x-axis, its y coordinate will be definitely 0, and the x coordinate we don't know. We will try to find out this. The given condition is that the AB length is equals to BC length. AB length is equals to BC length. So we know the coordinates of the 3 points, and we can apply the distance formula. You know the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. So I will apply the distance formula on the A and the B point. So you will have 6 minus 0 whole square plus 6 minus 4 whole square. So that is how you find the distance of the AB. 6 minus 0 is 6, and 6 minus 4 is 2. So 6 square and plus 2 square and under root on it. On the other side, the right side, you have BC. That's the given condition that AB length is equals to the BC length. So we will apply the distance formula on the B and the C point. This is B and the C point. So you will have x minus 6 whole square plus 0 minus 6 whole square and a square root on that. X minus 6 whole square plus minus 6 whole square. So here 6 square will be 36, 2 square will be 4. X minus 6 whole square, you know that x minus 6 whole square. We can open it as A minus B whole square. You remember the identity, A minus B whole square. That is A square minus 2AB plus B square. So here we have square of the first term minus 2 into first term into second term plus square of the second term plus minus 6 square will be 36. So here you have 36 plus 4, that will be 40 under root 40 equals to, it will be x square minus 12x plus 36 plus 36. So 40 under root, and here you will have x square, and here you will have minus 12x plus 36 is 72. So we will square both the sides, and when you square here, so that square root and this square will be cancelled. You're left with 40 only. So when you take the square of this side, this square and the square root will be cancelled. You are left with x square minus 12x plus 72. So now you have this x square minus 12x plus 72 minus 40 and equals to 0. I just forgot to write here equals to 0. So x square minus 12x plus 32 is equals to 0. So x square minus 8x, here we have done the midterm breaking. You see, we have to here we have to find a pair who by multiplying give you 32 plus 32, and by addition will give you 12 minus 12. So 8 and 4 are that pair. You multiply 8 and 4, it gives you 32. When you add them, this gives you 12 because we want minus 12. So with both of them, we will put negative sign. So here you have x square minus 8x minus 4x plus 32 equals to 0. We are doing the midterm breaking. From these first two terms, you can take x common. So I've taken x common. So you have x minus 8 From these two last terms, you can take -4 common. So here you will have x minus 8 equals 0. X minus 8 bracket is common. X minus 4 equals to 0. We will make both these. Here you have to write equals to 0. So x minus 8 equals to 0 because these two are multiplying and they are equal to 0. So we will make them 1 by 1 equals to 0. So you will have x minus 8 equals to 0 and x is equals to 8. Here you will have x minus 4 equals to 0, x equals to 4. So I think that you got the values of x. So there are two possible values of the c. The y coordinate of the c was 0. So it means that the c is either 8 comma 0 or the c is either 4 comma 0. So that was question number 8, A part. Let's move to the next part. So now on your screen, you can see we have question number 8 and its B part is showing up. In the B part, he says the point D on the y-axis such that the angle ABD is equals to 90. So we know the coordinates of A are 0, 4. The coordinates of the B are 6, 6. The point D is on the y-axis. If the point D is on the y-axis, then its x is 100% 0. So the coordinates of the D will be 0, y. And we know the given condition is the angle ABD is equals to 90. I'm here trying to show you so that you can understand that ABD is angle 90. It means that the line AB and the line BD, they are perpendicular to each other. If both these lines are perpendicular to each other, then the product of the gradient of the AB and the gradient of the BD will be equals to -1. So here you can see the gradient of the AB. I will find the gradient of the AB using these 2 points. You know the formula for the gradient is y2 minus y1 divided by x2 minus x1. So the gradient of the AB will be 6 minus 4 divided by 6 minus 0. The gradient of the BD will be y minus 6 divided by 0 minus 6. So equals to -1. So 4 minus 6 will be 2. 6 minus 0 will be 6. Y minus 6 as it is. And 0 minus 6 is -6 equals to -1. Okay, so you just multiply these two. The 2 will multiply with the y minus 6. You will have 2y minus 12 divided by -36 equals to -1. So let me show you. Here we have 2y minus 12 divided by -36 is equals to -1. Cross multiply here. So you will have 2y minus 12 equals to 36. 2y is equals to 36 plus 12. 2y is equals to 36 plus 12 is 48. Y is equals to 48 divided by 2. So y will be 24. So the gradient of the D will be 0, 24. So this is question number 8 from the exercise 6D. D3 is the name of the book. Hopefully you have understood this question. Let's move to the next question. The next question coming up on your screen is question number 9. And I'm going to read that question from the book. A point P is equidistant from R, whose coordinates are -2, 4, and S, whose coordinates are 6, -4. And its x coordinate is twice its y coordinate. The point P is such that its x coordinate is twice its y coordinate. So suppose the y coordinate is A, then the x coordinate will be 2a. He said the point P is such that its x coordinate is twice its y coordinate. So we suppose that the y coordinate is A. You can suppose it x, y, z, whatever you like, x, y, z, w, whatever name you like. So if the y is A, then the x will be 2a. So we now know the coordinates of the 3 points. The given condition is in the first part, he says, find the coordinates of P. A point P is equidistant from R and S. The point P is equidistant from R and S. Equidistant means that its distance from the R and its distance from the S is equal. So it means that the PR is equals to PS. PR is equals to the PS. So PR, I will apply the formula of the distance. The formula of the distance is x2 minus x1 whole square plus y2 minus y1 whole square. So P and R, I will apply the formula of the distance on P and R. So you will have 2a minus minus 2 whole square plus a minus 4 whole square and a square root on top of it equals to PS. So apply the distance formula on the PS. So you will have 2a minus 6 whole square plus a minus minus 4 whole square. So 2a minus minus will become plus. So you will have bracket 2a plus 2 bracket close whole square plus a minus 4 whole square equals to, this is 2a minus 6 whole square plus, this minus and minus will become plus. So you will have a plus 4 whole square. So I will open these whole squares with the help of the, algebraic identity. And the algebraic identity, we will use a plus b whole square is a square plus 2ab plus b square. And the negative a minus b whole square will be a square minus 2ab plus b square. You remember these identities, you have learned them in your 8th class. So I will apply the identity on this whole square. So you square of the first term plus 2 into first term into second term plus square of the second term plus. Now I will open this one. Square of the first term minus 2 into first term into second term plus square of the second term equals to. I will apply the whole square here, the identity. So you will have square of the first term minus 2 into first term into second term plus square of the second term plus, again I will apply the whole square identity here. So you will have a square plus 2 into first term into second term plus square of the second term. So here you will have 4a square plus 8a plus 4 plus a square minus 8a plus 16 and under root on this equals to, this will be 4a square minus 24a plus 36 plus a square plus 8a plus 16. So you will have here 5a square plus 20. This 8a and minus 8a will be cancelled. Here you will have 5a square minus 16a plus 52, and we have square root on both of them. So we will take square on both the sides. So on both the sides we will take the square. So you can see there, here we have taken the whole square on both the sides. So this square root will be cancelled with the square. So you are left with 5a square plus 20 equals to 5a square minus 16a plus 52. So we will have 5a square and 5a square, they both will be 5a square and 5a square, they both will be cancelled. You are left with this 16a. Bring to this side, 16a is equals to 52 minus 20, 16a equals to 32. So this 16 multiplying here, take it to the other side, divide, it will divide there. So a will be equals to 32 divided by 16. So that will be 2. So it means that the coordinates of the P, we suppose that they are 2a comma a. The value of the a is 2. So 2a means 4 and a means 2. So the coordinates of the P are 4 comma 2. So this is question number 9 and its first part. Okay, so question number 9, second part, he says that hence determine whether P, R, and S are collinear, showing you're working clearly. So if the point, I know the coordinates of the P, and I know the coordinates of P that are 4 comma 2, the coordinate of R are minus 2 comma 4, and the coordinates of the point S are 6 comma minus 4. So we will prove that they are collinear or they are not collinear. So what we will do, we will find the slope of the PR and PS. So if the slopes are same, then we will say they are collinear. The slope of the PR will be 2 minus 4 divided by, the formula is y2 minus y1 divided by x2 minus x1. You just apply the formula on the PR. The PR will be, you see, the 4 minus minus 2 divided by 2, 2 minus 4 divided by 4 minus minus 2. So 2 minus 4 divided by 4 minus minus 2, it will be minus 2 divided by 6 equals to minus 1 by 3. And the slope of the PS will be PS. The PS will be, P and S. So we will have 2 minus minus 4 divided by 4 minus 6. So let me show you here. Okay, 2 minus minus 4 divided by 4 minus 6, y2 minus y1 divided by x2 minus x1. So we will have 6 divided by minus 2, and that will be minus 3. You can see the gradient of both the lines PR and the PS is not same. So from here we can say that the point P, R, and S are not collinear. So the point P, R, and S are not collinear. So this was the question number 9 of the exercise 6D from the book D3. Hopefully you have understood. Okay, so let's move to the next question. The next question coming up on your screen is question number 10. And I'm reading the question from the book. The coordinates of 3 points are: A point is minus 1 comma minus 6, B point is 3 comma minus 12, and the C point is K comma 6. Find the value of the K if A part is A, B, and C are collinear. You know, if A, B, and C, if the A, B, C are collinear, means they are in the same line. So the gradient of the AB and the gradient of the AC will be same. So here you can see, according to the condition I have written, the gradient of the AB is equals to the M, or the gradient of the AC. So we apply the formula of the gradient of the AB. So it will be minus 12 minus minus 6, so it will become plus 6, divided by 3 minus minus 1, and it will become plus 1. So you have minus 12 plus 6 divided by 3 plus 1 equals to AC. The gradient of the AC will be 6 minus minus 6. It will become 6 plus 6. K minus minus 1. So it becomes K plus 1. So minus 6 minus 12 plus 6, it will be minus 6. And 3 plus 1 will be 4. 6 plus 6 will be 12. K plus 1 will be K plus 1. So you have, here we will cross multiply. So you will have minus 6 bracket K plus 1 equals to 4 multiplied 12. That will be 48. So you have minus 6K minus 6 equals to 48 minus 6K. This minus 6 will go on the other side. It will add. So you will have minus 6K equals to 54. So K will be equals to 54 divided by minus 6. So the K value will be minus 9. So this is question number 10, A part. Hopefully you have understood. Let's move to the next part. So on your screen, the question number 10, and its B part is showing up. And I'm reading that question from the book. It says the coordinates of the 3 points are A minus 1 comma 6, B 3 comma minus 12, and C is K comma 6. Find the value of the K if AB is perpendicular to AC. If it is given that the AB is perpendicular to AC, if both these lines AB and the AC, they are perpendicular to each other, the product of their gradients will be equals to minus 1. So the gradient of AB multiply the gradient of the AC equals to minus 1. So we will apply the gradient formula on the AB. That will be minus 12 plus 6 divided by 3 plus 1 equals to, sorry, not equals to, multiply with. The gradient of the AC will be 6 plus 6 and divided by K plus 1 equals to minus 1. So minus 6 plus 6, it will be minus 6. 4 plus 1, 3 plus 1 will be 4. 6 plus 6 will be 12. K plus 1 will remain as K plus 1. So this 4 and this 12 will be cancelled. 4 ones are, 4 threes are. So 3 multiplied with the minus 6 will be minus 18 divided by K plus 1 equals to minus 1. So we will cross multiply. So you will have minus 1 into K plus 1 equals to minus 18, minus K minus 1 equals to minus 18, minus K equals to minus 18 plus 1, minus K equals to minus 17. So negative and negative will be cancelled. So the K will be equals to 17. So this is how we will do the question number 10. Is B part. Hopefully you have understood the story and the solution both. So let's move to the next question. The next question coming up on your screen is question number 11. And I'm reading that question from the book. The question says the coordinates of the 3 points are: point A is minus 1 comma minus 3. The point B is 2 comma 3. The point and the C point is 6 comma K. If AB is perpendicular to BC, find the value of the K. So we have the 3 points, their coordinates are given. It is also given that the AB line is perpendicular to the BC line. And you know, if the two lines are perpendicular to each other, the product of their gradient will be equals to the -1. So if the AB is perpendicular to the BC, so the gradient of the AB multiplied gradient of the BC will be equals to -1. So let's apply the gradient formula on the AB. You know, the gradient is equals to y2 minus y1 divided by x2 minus x1. So you will have AB 3 minus 3, that becomes 3 plus 3 divided by 2 minus 1, so it becomes 2 plus 1. In the same way, BC, it will be k minus 3 divided by 6 minus 2 and equals to -1. So 3 plus 3 is 6, 2 plus 1 is 3, k minus 3 will remain as it is, 6 minus 2 will be 4, and when you multiply that, we have cancelled it, 3 ones are, 3 twos are, 2 ones are, 2 twos are, so you are left with k minus 3 divided by 2 equals to -1. So just cross multiply, k minus 3 is equals to -1 multiply 2. So k minus 3 is equals to -2. So k is equals to -2 plus 3, k is equals to 1. So we know the value of the k, that is 1. Now the B question is find the gradient of the AC. Now I know the I know the coordinates of the point A. They are -1, -3. The point C, its gradient is 6, k. The value of the k we know is 1. So the coordinates of the C are 6, 1. So I can very easily find the gradient of the AC. The formula is y2 minus y1 divided by x2 minus x1. So 1 minus -3, it will become +3. 6 minus -1, it will become 6 plus 1. 3 plus 1 is 4. 6 plus 1 is 7. So the gradient of the line AC is 4 by 7. So this was question number 11 and its B part. I hope that you have understood this question. We are doing exercise 6D from the book D3. Okay, so here we go. This is question number. So the question number 12 is showing up on your screen. Let me read the question from the book. The question says, determine whether the 4 points 2, 1, -1, -5, 1, 5, -2, -1 are the vertices of a parallelogram, showing your working clearly. So here in this question, there is one very important trick to understand is, normally what happens, we join the points to make that parallelogram in the same order in which the points are given in the question. Normally this happens and they make a perfect parallelogram. But here there is a trick. You put those points on a rough grid. You can see there, I have made those grids here. I have given the points supposed names also, A, B, C, and D. You see, when I plotted those points on the grid, and by using common sense, I joined the points. The name of the parallelogram came out to be A, B, D, C instead of A, B, C, D. The name of the parallelogram, very important point, the name of the parallelogram is ABDC, a very important thing. So we have to show that these are the vertices of a parallelogram. Okay, so I will find the slope of in the parallelogram, you know, there are 2 characteristics. The one characteristic is that the opposite sides have the same gradient and the opposite sides also have the same length. So here I'm going to prove that these are the vertices of parallelogram by simply showing that the opposite sides are parallel to each other. If the opposite sides will have the same gradient, that will show that they are parallel to each other. So for that purpose, I will find the gradient of the AB, I will find the gradient of the BD, I will find the gradient of the DC, and then I will find the gradient of the CA. And we will see that by finding the gradient, we will see that the gradient of the AB will be equals to the gradient of the DC. In the same way, we will see that the gradient of the BD will be equal to the gradient of the AC or CA. So let's find the gradient of the AB. The gradient of the AB will be 2 minus 1, 1 minus 5. That will be 1 plus 5, and 2 minus 1, that will be 2 plus 1. I'm using the formula of the gradient, which is y2 minus y1 divided by x2 minus x1. So we will have 1 plus 5, that will be 6, 2 plus 1, that will be 3, 6 by 3 is 2. So the gradient of the AB side is 2. Now we find the gradient of the BD. So the gradient of the BD will be minus 5 minus 1. It will be minus 5 plus 1. And minus 1 minus 2, it will be minus 1 plus 2. So minus 5 plus 1 is minus 4. Minus 1 plus 2 is 1. So the gradient of the BD will be minus 4. In the same way, I will find the gradient of the DC line, and that will be 5 minus 1. It will make 5 plus 1. So 1 minus 2, it will make it 1 plus 2. So 5 plus 1 is 6. 1 plus 2 is 3. 6 by 3 is 2. So in the same way, I will find the gradient of the CA line. It will be 5 minus, so it will be 1 minus 5 divided by 2 minus 1. And you will have 1 minus 5 is minus 4. 2 minus 1 is 1. So it will be minus 4. So you can see clearly that the gradient of the AB and the gradient of the DC, they are equal, so they are parallel. So AB is parallel to DC. In the same way, the BD, the gradient of the BD and the gradient of the CA, they are equal to each other, which means they are parallel to each other. So this proves, because the opposite sides in this quadrilateral, the opposite sides have the same gradient. So this means that this is a parallelogram. We can also use that strategy that we can find the length of the AB, the length of the BD, and the length of the DC, and the length of the AC. And you will see that the AB length and the DC length, they will be equal to each other. And the BD length and the AC length, they will be equal to each other. That can be also, this is how we prove that this is a parallelogram. By the gradients, we can also prove that these are the vertices of a parallelogram, because the opposite sides are parallel to each other. So that was question number 12. Hopefully you have understood. Let's move to the next question. So the next question showing up on your screen is question number 13. And I'm going to read that question from the book. It says, determine whether the 4 points, 5, 8, that's the A point, B point is 7, 5, C point is 3, 5, and the D point is 5, 2, are the vertices of a rhombus, showing your working clearly. You see, we have to prove that these are the vertices of a rhombus. And if you want to show that these are the vertices of a rhombus, so first of all, for our own understanding, what I have done, I have made a rough grid and I have plotted those points on the grid. And then I joined them so that they appears to be a rhombus. So, and the very important thing is that after plotting them on a grid and then joining them, I came to know that the order in which they are joined with each other is A, B, D, C. A, B, D, C. The name is quite different. So now if you want to prove that these are the vertices of the rhombus, you know the rhombus is the parallelogram and its 4 sides are equal in length. So if you want to prove that this is a rhombus, what you will do, you will find the length of the 4 sides. So I will find the length of the AB, I will find the length of the BD, I will find the length of the CD, I will find the length of the AC. So, and I will see that when we will find these lengths, you will see that they are equal. They all are equal. So here you can see that I have applied the distance formula on the AB. The distance formula is x2 minus x1 whole square plus y2 minus y1 whole square, and the square root on top of everything. So you will have 7 minus 5 whole square plus 5 minus 8 whole square. To just enter this thing in your calculator. So you will have 2 square plus it will be minus 3 whole square. So that will give you, and you do this calculation, the final answer will be 3.60. Apply the distance formula on the BD and apply the distance formula on CD, apply the distance formula on the AC, you will see all of them have the same length. So the one characteristic of the rhombus is all its four sides are equal in length. So we have proven that all the four sides are equal in length. Another important thing about rhombus is that its opposite sides are parallel to each other. So we will find the gradient of the AB, the gradient of the BD, we will find the gradient of the DC, and we will find the gradient of the AC. So here you can see that I have tried to find out the gradient of the AB, and the formula is very simple. It's y2 minus y1 divided by x2 minus x1. So here we have 5 minus, so we will have 5 minus 8 divided by 7 minus 5. It will be minus 3 by 2. And in the same way, I will find the gradient of the BD. It will be 2 minus 5 divided by 5 minus 7. It will be minus 3 divided by minus 2, and it will be 3 by 2. Gradient of the CD will be 2 minus 5 divided by 5 minus 3, and that will be minus 3 by 2. And the gradient of the AC will be, 5 minus 8 divided by 3 minus 5, and it will be minus 3 divided by minus 1, that will be 3 by 2. So you can see the gradient of the BD, and the gradient of the AC are equal. So it means the opposite sides have the same gradient, so they are parallel to each other. And you know the gradient of the AB and the gradient of the CD, they are equal, which means they are parallel to each other. So you can see that the opposite sides are parallel to each other. So with this means that it's a parallelogram. All the four sides of this parallelogram are equal to each other, and it's a parallelogram. So that kind of parallelogram whose four sides are equal to each other is known as rhombus. So we have proven that these 4 points are the vertices of a rhombus. So this is how you will do question number 13. Hopefully you have understood that how the question is done. Question number 13. So we have on your screen question number 14 showing up. Let me read it from the book. The coordinates of the 3 points are: A point is -1, minus 6, B point is 3, 12, and the C point is K, 6. Find the values of K if the A point is, find the value of the K if A, B, and C are collinear. If A, B, and C are collinear, collinear means they are in the same line. If they are collinear, then the gradient of the AB and the gradient of the AC, they will be equals to each other. So apply the formula of the gradient on the AB and the gradient formula on the point A and C, and make them equals to each other. Here you can see we have shown the gradient formula. So AB, that will be 12 minus 6 divided by 3 minus 1. So it will be 12 plus 6, and that will be 18. 3 plus 1, that will be 4. On the other side, AC, so the formula will be 6 minus 6, it will be 12, and K minus 1, it will be K plus 1. So here you cancel it with the 2, so 9 by 2 is equals to 12 by K plus 1. So from here you can cross multiply it. You can see here. So we have cross 9K plus 9 is equals to 24. So we will have 9K. So you will have, let me move it. Okay, so you will have 9K equals to 24 minus 9. 9K is equals to, here you can see is 15. So K will be equals to 15 by 9, and K will be 5 by 3. K will be 5 by 3. So we found the value of the K. So that is question number 14, A part. Hopefully you have understood. Now on your screen, we are showing question number, this is question number The question number 14, B part is showing up. We know the coordinates of A, that is -1, -6. The point B, 3, 12, and the point C is K, 6. Find the value of the K if the AB is perpendicular to AC. It is given AB is perpendicular to AC. If both these lines are perpendicular to each other, then the product of their gradients will be equals to -1. So the gradient of the AB multiply the gradient of the AC is equals to -1. So I have applied the distance, the gradient formula on the AB point. So the gradient will be 12 minus 6 divided by 3 minus 1. And the gradient of the AC will be 6 minus 6. K minus 1, so it will be 18 by 4, and it will be 12 divided by K plus 1. So here you have considered with the 2, so it will be 9 by 2, and here this 2 will be cancelled with this 12, it will be 6. So we will have 9 into 6 divided by K plus 1 equals to -1. So it will be 54 divided by K plus 1 equals to -1. So cross multiply. So you will have 54 is equals to minus K minus 1. So take the K to the other side, bring the 54 to this side. So you will have K is equals to -1 minus 54. So K will be equals to -55. So this is how you do the question number 14B part. And let's move to the next part. That is question number 14C part. Let me read it from the book. He says the coordinates of the 3 points are: point A is -1, -6, point B is 3, 12, and the C point is K, 6. Find the value of the K if BC is perpendicular to AC. BC is perpendicular to AC. So here you can see that we have written that condition that the BC is perpendicular to AC. So the gradient of the, because these two lines are perpendicular to each other, so the product of their gradients will be equals to -1. Gradient of the BC multiplied with the gradient of the AC will be equals to -1. So we apply the formula of the gradient on the B and the C point. It will be 12 minus 6 divided by 3 minus K multiply 6 minus 6 and K minus 1. So you will have 6 divided by 3 minus K, and here you will have 12 divided by K plus 1 equals to -1. And numerator multiplies numerator, denominator multiplies denominator. So you will have 6 multiplied 12, that's 72. When you multiply these two brackets, you will have 3K plus 3 minus K square minus K equals to -1. So 72, so downstairs we will have minus K square plus 2K plus 3 equals to -1. Just cross multiply. So this -1 will multiply with this thing. So you will have K square minus 2K minus 3 equals to 72. Bring this 72 to the left side. So you will have K square minus 2K minus 75 equals to 0. So here midterm breaking cannot be done. So we will apply the distance. We will apply the quadratic formula. So the value of the A here is 1, and the value of the B is -2, and the value of C is -75. So we have applied the quadratic formula here. K is equals to, the minus B plus minus under root B square minus 4AC whole divided by 2A. Just substitute these values here. So you will have at the end, when you do this quadratic formula, at the end, the K value will be 9.72 and comma -6.7. So we found the value of the K. So there are two values of K in the question number 14 C part. Hopefully you understand this. Hopefully you know how to apply the quadratic formula. I hope that you have done chapter number 1 of the D3, where we have learned about the quadratic formulas. So hopefully you understand this question. This was question number 14 and exercise was 60. Okay, so we are moving to the next question. The next question showing up on your screen is question number 15, exercise 6D from the D3. Question number 15, and I'm reading it from the book. The coordinates of the vertices of a triangle ABC, the name of the triangle is ABC, are point A 1, 2, point B 6,7, and point C 7,2. Find the equations of the perpendicular bisectors of. We have to find out the equations of the perpendicular bisectors of the side AB and the side BC. You know the perpendicular bisector. What's the meaning of the perpendicular bisector? Meaning of the perpendicular bisector of the AB will be a line which passes through the midpoint of the AB and is perpendicular to the AB. So what is the meaning of the perpendicular bisector of the BC side? A line which passes through the midpoint of the BC line and is perpendicular to the BC. So we have to find out the equation of those both the perpendicular bisectors. So first of all, I need to find out the midpoint of the AB line. The coordinate of A and B is given. If you want to find out the midpoint of the AB line, the formula is very simple. The coordinates of the midpoint are x2 plus x1 divided by 2, x2 plus x1 divided by 2, comma y2 plus y1 divided by 2. So if you want to find out the midpoint of AB, I'm calling it M1, capital M1. So I will see x2 plus x1 divided by 2, 6 plus 1 divided by 2, y2 plus y1 divided by 2, x2 plus x1 divided by 2, comma y2 plus y1 divided by 2. So the M1 will be 7 by 2, comma 9 by 2. So the M1, the coordinates of the midpoint of AB are 7 by 2, comma 9 by 2. And if you want to find out the midpoint of the BC, same formula, x2 plus x1 divided by 2, comma y2 plus y1 divided by 2, 7 plus 6 divided by 2, comma 2 plus 7 divided by 2. 7 plus 6 is 13, so it will be 13 by 2. 7 plus 2 is 9, 9 by 2. So the coordinates of the midpoint of BC are this. We just found the midpoint of the AC also, so you know how to find the midpoint. So, but we will not require that. Okay, now we will find the gradient of the AB. We know the coordinates of AB, so that will the gradient of the AB will be 7 minus 2 divided by 6 minus 1. So that will be 5 by 5, and that will be 1. In the same way, find the gradient of the BC side. So BC side will, the gradient of the BC will be 2 minus 7 divided by 7 minus 6. And it will be minus 5 divided by 1, and it will be minus 1. And in the same way, we found the gradient of the AC. We will not require that. So the equation of the perpendicular bisector of the AB, you know, the perpendicular bisector of the AB, it will be passing from the midpoint of the AB. The midpoint of the AB was 7 by 2, comma 9 by 2. And the perpendicular to AB, you know, the gradient of the AB, the gradient of the AB, the gradient of the AB is 1. So the gradient of the perpendicular to the AB will be minus 1. It will be reciprocal and its sign will change. So here we have found the equation of that that perpendicular bisector. Y minus y1 equals to m bracket x minus x1. So this point is y is 9 by 2 equals to the gradient of the perpendicular will be minus 1 bracket, and the x1 will be 7 by 2. So take the LCM here. So you will have 2y minus 9 upstairs equals 2. Here you can take the LCM. It will be 2x minus 7. So you will have 2y minus 9. This 2 and this 2 will be cancelled. So you will have 2y minus 9 equals to minus 2x plus 7. So you will have 2y equals to minus 2x plus, when this negative minus 9 will come here, it will add, it becomes 16. So you will have y equals to minus x plus 8. So that is the equation of the perpendicular bisector of the AB. In the same way, we can find the perpendicular bisector of the BC. We know the midpoint or of the BC is M2. It was 13 by 2, comma 9 by 2. And the gradient of the BC is -5. So the gradient of the perpendicular to the BC will be reciprocal and the sign change. And it will be 1 by 5. So apply the formula for the equation, that is y minus y1 equals to m bracket x minus x1. So y1 here is 9 by 2 equals to m is 1 by 5 into bracket x minus x1 is 13 by 2. Find the LCM. So 2y minus 9 equals to 1 by 5 into find the LCM inside this bracket, that will be 2. So here you will have 2x minus 13, 2 and 2 will be cancelled. And take this 5 to this side, so you will have 10y minus 45 equals to 2x minus 13. So 10y is equals to 2x plus 32. Divide all the terms with 2, you will have 5y equals to x plus 16. So this is how you will do question number 15. So that was the question number 15, the start of the question. And this is how this has finished. Okay. So hopefully you have understood. Just forget this thing, this number here. I don't know if my student wrote this on the board. Actually, here the point is this, and the gradient reciprocal of this and sign change. So it is -1. Hopefully you have understood. This was the question number 15, and hopefully you have understood. And let's move to the next part. And that's the last question of the exercise 6D. So that is coming up on your screen. I'm reading the question from the book, and it says that the coordinates of the vertices of a square are point A, 4, 0, and they have shown the diagram as well on this. The diagram is also shown in the question. The point B is -3, 1. The point C is -2, 8. And the D is 5, 7. The diagram is already in the question, so you can see if you have the book with you. The question is find the gradient of the line segment joining the point A, which is 4, 0, and the C, which is -2, 8. So the gradient of the AC, very simple question, A and C, just apply the gradient formula, that is y2 minus y1 divided by x2 minus x1. So we will have 8 minus 0 divided by -2 minus 4. So we will have 8 divided by -6, that will be equals to, with the 2 we have cancelled. So -4 divided by 3. So that's the gradient of the AC. So that was the first part of this question, question number 16. The second part is, given that B is the point -3, 1, explain why the AB is equals to BC and that the angle ABC is 90 degree, showing you're working clearly. So we have to show that the AB length and the BC length, they are equal. So we will apply the distance formula on the AB. Okay, so the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. So -3 minus 4 whole square plus 1 minus 0 whole square, -3 minus 4 will be -7, its whole square will be 49, and 1 square will be 1. So 49 plus 1 will be 50, and the root of the 50 will be 7.07. In the same way, I will apply the distance formula on the BC. BC you can see here. So it will be -3 minus 2. So that will be -3 plus 2. That will be -1 whole square. That will be 1. So 1 minus 8, that is 7, minus 7 square will be 49. So 1 plus 49 will be 50, and under root of the 50 will be 7.07. So you can see here we have shown that the length of the AB and the length of the BC, they are equal to each other. They are the adjacent sides of that square, and you know, because they are sides of square, so they are supposed to be equal to each other. In the same way, he says that to prove that the angle ABC is 90 degree. ABC. It means that the AB and the BC are perpendicular to each other. So find the gradient of the AB, apply the gradient formula on the A and B point. The gradient formula is y2 minus y1 divided by x2 minus x1. So 1 minus 0 or 0 minus 1, I have done this, 0 minus 1 divided by 4 minus 3. So it becomes 4 plus 3. So 0 minus 1 is minus 1 divided by 7. So the gradient of the AB is minus 1 by 7. In the same way, the gradient of the BC will be B and C. It will be 1 minus 8 divided by minus 3 minus 2. It will be minus 3 plus 2. So you will have minus 7 divided by minus 1. Minus will be cancelled. It will be 7. So when you multiply the gradient of these two lines, M of AB and M of BC, you see you get the product is minus 1. So if the gradient, the product of the gradient of the AB and the BC is equals to minus 1, that shows that the AB is perpendicular to BC, which means that the angle ABC is 90. So this is how you prove that the AB and the BC are equal and the ABC angle is 90 degree. Hopefully you have understood. And the third part is hence or otherwise. Calculate the area of this square. We know the side of this square. The side of this square is 7.07. So if you want to find out the area of the square is L square, the square of the side. So 7.07 square is 50. So the area of this square will be 50, and you can write with it unit square. So my dear students, this was question number 16, and we are done with the exercise 6D. And hopefully you have understood this, and you know that today we have finished this exercise, the exercise 6D. And I hope that this lesson, this video is helpful to you. And I've tried my best to explain all the concepts and all the steps and all the procedures which were involved. And remember one thing, that the D3 we are working on, it requires a basic knowledge which you have studied in your D2 book. The chapter number 3, chapter number 4, 5, 6 from the D2. You should have command on those chapters, because the procedures which involved in this exercise, they require that knowledge. Okay, so thank you very much, everybody. Hopefully this was a great and a very helpful lesson to you. If this video is helpful to you, don't forget to subscribe to my channel, and also suggest these videos to your friends, to your class fellows, by uploading the link or sharing the link in your Facebooks and your Instagrams. That will be a great appreciation and help for me. So thank you very much, everybody, and have a good day. And God bless you all. So thank you very much. Bye-bye.